Greetings, M squared here. Today we're starting our notes on Chapter 8, Topic 8, and our learning target for today is to identify some key features of a quadratic function. And some of those key features are vertex, axis of symmetry, the direction of the graph, that means whether it opens up or down. We're also going to talk about domain and range and a few other things. So we are going to get started. Each function has a parent function. It's the simplest kind of that function. A quadratic parent function looks like this. F of x equals x squared. Remember, we could also say y equals x squared. But f of x equals x squared. So it is the simplest form of that function in the quadratic function family. And we're going to talk about how they shift and get flipped and all those other things. But you need to know that the graph of a quadratic function is called a parabola. That's what we call it. The shape of a linear function is called a line. The shape of a quadratic function is called a parabola. And it looks like this. It could also be upside down. It could also be skinnier and wider, but it's basically, we call that kind of a U shape, but it's called a parabola. And we're going to kind of just look at that basic parent function. We're going to fill out a table with points. Well, anytime I want to graph a function, no matter what it is, I can always take the function, put in an x, any x I want, get out a y, get the point, and then graph all those points. And then that helps me know what the function looks like. So if I put a -2 in here, that's the same as f of -2. Remember, we replaced the x with -2, so that would be -2 squared. And -2 squared is 4. So my point would be -2, 4. I'm going to do that again with all of these numbers. So f of -1 squared is 1, so my point would be -1, 1. If I find f of 0, I get 0, because 0 squared is 0, so the point I have is 0, 0. I can find f of 1, 1 squared is 1, f of 2, 2 squared is 4, so then my points are 1, 1, and 2, 4. What I want you to notice is that, first of all, it's decreasing here. Do you see that it's going down? Sorry, that's not how you spell decreasing. It's decreasing here. 4, 1, 0, but it's increasing on this side. 0 goes from 1 to 4, so it's increasing. We're going to talk about increasing and decreasing in a little bit. But let's graph these points. So I'm going to graph all of these points over here. Now remember, because I just told you that a quadratic function, remember we learned that from last chapter, the highest exponent is a 2, it's called quadratic. When a quadratic function is graphed, it becomes a parabola, or it looks like a parabola, that's what we call it. So we expect this to look like that. If you know what it's supposed to look like, and then you find points and it doesn't look like what you know it's supposed to look like, that means you made a mistake. So it's really important to have that idea in your mind of what it's going to look like. So we're going to go over here to our graph, and our first point was -2, 4, and then -1, 1, 0, 0, 1, 1, and 2, 4. And we can see that if we connect those dots in order, we get this U-shaped. Now a parabola has some features, and we're going to talk about that next, the different features, and that's going to be part of your homework today, is figuring out what those features are. So we have a vertex. A vertex is the turning point of a parabola. Just like in our chart, we noticed that it's decreasing and then increasing. When we talk about increasing and decreasing on a graph, we are always talking about as x moves from left to right, is y increasing or decreasing. So if I catch this right here, do you see how I'm going down? And then I go back up. So it's decreasing until right here, and then it starts increasing again. And that turning point where it stops increasing and starts decreasing, or vice versa, that is called the vertex of the parabola. Now the vertex is the minimum point, the lowest point if the parabola opens up, but it is the maximum point if the parabola opens down. You're going to be asked questions like that. What is the minimum or what is the maximum of this equation, function, graph? And you need to know that that's what it's talking about. It's talking about the vertex. The other thing is, another feature is the axis of symmetry. See this little dashed line in our picture? That's the axis of symmetry. in these type of parabolas, because when you get into pre-calculus, sometimes algebra 2, the parabolas can also go left and right. Our parabolas only go up or down. So in our case, it's going to be a vertical line that goes through the vertex and cuts the parabola into two congruent sections. So it's important that you know the axis of symmetry always goes through the vertex. Why is that really important? Because if you know it goes through the vertex and you know it's a vertical line, remember all vertical lines are x equals some number. So if we know the vertex, for example, this one looks like it's about, well, we'll just call it 2, -4. We'll say that that's what that point is. If we know that, and we know that vertical lines go through the only have an x equals, then I just say, hey, what's my x there on my vertex? And I can write the equation of my axis of symmetry by just knowing what the x of my vertex is. So that would be x equals 2. That would be my axis of symmetry, and this would be my vertex. And sometimes I put a little v for vertex. All right. So there are different ways to look at an equation and tell what kind of parabola we have, whether it opens up or down, whether it's stretched or compressed. And we're going to first talk about what the direction of the graph is. How can you look at the equation, not the graph? Because if you're looking at the graph, you can tell whether it opens up or down. But if you're looking at the equation, how can you tell whether it opens up or down? And it's all about A. So remember, we last chapter when we were factoring, we talked about this ax squared plus bx plus c. This is a form of a quadratic equation, or function, I should say, or expression. A is always in front of x squared, b is always in front of x, and c is the constant. Remember, those are all lowercase letters. So when we are talking about a, we're talking about what's in front of a squared. Only what's in front of x squared, sorry. Not what's in front of x, not what's in front of c. It's only about x squared. So even if they're not in standard form like this one, you would always look at x squared and in front of it to determine what the a is. So the a value determines whether a graph opens up or down. And in this case, when a is less than 0, remember, less than 0 numbers are negative, then the parabola would open down. So some examples of that would be if I had negative x squared, or y equals negative 2x squared, or f of x equals negative 1/2 x squared. All of these I know would open down because a is less than 0. If a is greater than 0, my parabola is going to open up. So some examples of that would be f of x equals 4x squared, or y equals just plain old x squared. Those are going to open up. So when you look at a function, you just determine whether it opens up or down by looking at a. So we're going to go through a few of these. For example, I look for my x squared. Is a positive or negative? Well, a is bigger than 0. It's 3, right? A is 3, and 3 is bigger than 0, so I know my parabola opens up. And you can just draw a picture in your notes on this, or you can say up. It doesn't matter. I'm going to probably just draw a picture. So there's my x squared. I look at the negative. It opens down. So I'm just asking, do these open up or down? Remember, when there's not a number, it's a 1. So that would be 1. 1 is bigger than 0, so I know it opens up. Here we have a 2. A is 2, so that means it opens up because it's bigger than 0. 1.6 still opens up. Doesn't matter if it's a decimal. It matters if it's positive or negative. This is negative 4. That's going to open down. Here's positive 4 for A. That means it's going to open up. And then this one looks a little tricky, right? You're going to have to multiply that out and do all sorts of things, but I can tell that if I multiply this out, I'd get an x squared, and then I would multiply it by negative 2. So right here, that's my new a. And this is a vertex form, and we're going to learn about that later, but if it's in this kind of form with the squared over here in right outside the parentheses, then the number in front of here is a. That's negative, so it's going to open down. And then this one, don't get tricked, because this is positive, but that's x. So this is not in standard form. That is a negative 3. So I know it opens down. Okay, so that's how you tell whether a graph opens up or down. A tells us two things, though. So now we're going to talk about what A tells us in terms of if it's vertically stretched or vertically compressed. And if you got on Desmos graphing calculator and you just put in a bunch of different quadratic functions and you just change whatever's in front of a squared. We'll do that in class, but you can kind of see whether it's getting what I call wider or skinnier, right? So we got a vertically compressed and a vertically stretched. For example, if this was the regular one, then a vertically compressed one would be wider. It would look more like that, and a vertically stretched one would look like that. So it would go up steeper or go up slower. So that's what we mean when we say vertically compressed or vertically stretched. And notice this is the absolute value of A. So we ignore the negative or positive here and just look at the absolute value of A. If it's between 0 and 1, it's vertically compressed. If it's bigger than 1, it's vertically stretched. So some examples would be negative 4x squared, or f of x equals 1.7x squared. The a's are bigger, absolute value of a's are bigger than 1. Over here, they're between 0 and 1. So we'd have f of x equals 1/2 x squared, or f of x equals negative 1/4 x squared. Those are going to be wider. They might be facing up or down. That's not what we're talking about. We're just talking about whether it's wider. So this one would be wider. But I want you to say vertically compressed. That's the mathematical term. This is kind of the layman's term. And then this would be skinnier. That's usually what I say. It looks a little skinnier, goes up faster on the sides. Skinnier. All right, so let's see. So are these vertically stretched or vertically compressed? If you want to, we'll say VS and VC. We'll use abbreviations. So we first find A. The absolute value of A is 1/4, right? Here it's negative 0.3. Here it's 1.6. And then here, remember, A is right there. So A is 12. A is 2/7, negative 2/7, and here A is negative 5/2. Now that we have our A's, let's put it in a little formula, right? We just have to know, is it between 0 and 1, or is it greater than 1? So the absolute value of that is between 0 and 1. So we know that this is vertically compressed. It's going to look a little wider. Again, the absolute value of that is between 0 and 1, because 0.3 is between 0 and 1. So it is also vertically compressed. 1.6 is bigger than 1, so we know that this is vertically stretched. 12 is definitely bigger than 1. We know that's vertically stretched. Negative 2/7, well, positive 2/7, because we're doing the absolute value, is less than 1, so that's vertically compressed. And here, 5/2, right? That's 2.5. If you need to change it to a decimal to figure it out, go for it. That's definitely bigger than 1, because 2/2 would be 1. So this is vertically stretched. So that is how you tell whether a parabola is vertically compressed or vertically stretched. So we've learned about whether it opens up or down and whether it's vertically stretched or compressed, and that is all about A, that number in front of the x squared. So what we're going to do here is we're going to review all of those wonderful things. Oh, but before we do, we're going to talk about domain and range. So we did that a while ago, domain and range. Remember, domain is all the possible x values, range is all the possible y values. You'll see these little arrows on all of these. Parabolas go left forever and right forever, the type of parabolas that we're doing. And so that makes our domain all real numbers all the time. So any parabola that you get in Algebra 1, because we don't learn about the other kind until later, any one you get is going to be all real numbers for domain, because it goes left and right forever. But you can see it doesn't go up. This one doesn't go up forever. It goes down forever, but it doesn't go up forever. Well, where does it start going down? It starts right there. So it's going to be really important for us to know what the vertex is. That's going to be the first thing we want to do, is find the vertex. So in these examples, we're going to find the vertex on all of those. I don't think I'm going to do all of them right now. I'll let you do some of them, but I'm going to do all of these for a couple. Okay, I'll probably do 1 and 3 since we got one up and one down. So first of all, what's the vertex of each parabola? Let's look at number 1. It looks like I go over 4 and down 1. So remember, the left and right is the x. That's where I put the x coordinate, and then my up or down is the last one. So x comma y. That's how we draw right points, x comma y. So my vertex for number 1 is 4, negative 1. And then we'll jump over here. The vertex for this one looks like 1, 2. So I'm just going to do 2 of these for you, and we'll do the rest, let you do the rest in class. All right, and here, what is the axis of symmetry for each parabola? Remember, the axis of symmetry is always an x equals line, so that's done. And if I know what the vertex is, I just say, well, which one's x? Well, that one's x, so it's got to be x equals 1. Which one's x? 4. So once you have the vertex, axis of symmetry is pretty easy. If you remember, it's always a vertical line, which means it only has an x, and it always goes through the vertex. And so that x coordinate tells you what it is. Does the parabola open up or down? Well, I can see it, right? This one opens down and this one opens up. So I'm going to say that. This one opens down, this one opens up. What is the A for each parabola? We have not talked about what the A is yet. So I'm just going to show you just for fun, and then we'll talk about that next time. Okay, so here's how I determine the A. I look at my vertex and I see how many do I go over and down. So I see I go over 1, down 1. I know that pattern, and we're going to talk about that pattern later, but because it's upside down, I know A is going to be negative, and because I went over 1, down 1, I know that A is negative 1. And again, we'll talk about that later because that's next class period. Let's look at this one. I go over 1, up 1, so I know it's positive 1. I'll just show you on these two just for fun. I go over 1. Notice you're counting by 2, so you got to be careful there. I go over 1 and down 1, 2, 3. So if I went over 1 and down 3, I would know it's a negative 3. And for this one, over 1, up 2, so I would know A is 2. And those didn't have any fractions, so you didn't, we'll do the fraction ones later. So this one was A is negative 3, and this one's A is 2. And again, we didn't talk about that this video. We'll talk about that the next video. What is the domain and range? Okay, remember, domain is all real numbers. That's always going to be in all of them, but I was just going to do these two. All real numbers, okay? But let's talk about the range. So we go up here, and we notice that it starts at, remember, range is y, so I need to know what the y coordinate of that is. This is the y, and then it goes down forever. Remember, okay, it's about y, so I say y is less than or equal to negative 1, right? Here's my y. That tells me I'm talking about range. And I'm going down because it was upside down. The parabola opened down. And then I just pick the highest y and say, oh, it has to be lower than that. And so this one, I pick the lowest y. So that point right there again was 2, 1. So here's my y, but it goes up from that. So my range would be y is greater than or equal to 1. And finally, is the parabola vertically stretched or compressed? Well, we can kind of look. This is the x squared when A is 1 here. So we know that this one is neither stretched or compressed because A was 1. And this was neither. I'm going to say neither. And this one was also neither. But you can kind of tell this one's a little bit skinnier, and this one's a little bit skinnier, so you can kind of tell that those are. So that would be vertically stretched, vertically stretched, vertically stretched, vertically stretched. And again, we are going to talk in more detail about how to write these equations and how to figure out what the equation is from the graph. All right, good luck with your homework. M squared, signing out.